Marina, thank you. Marina, thank you very much. And again, yeah, Michael Moore, Program Director of USCA, for those that have not met. I have the honor of running the traps with CJ and Daniel in interaction with tribal carbon capture, fossil fuel, decarbonization, and other kind of efficiencies for tribal resources. In fact, we've been running together for a number of years with several other efforts as well. In this particular case, they're driving a series of webinars with us under the National Tribal Energy Roundtable moniker. Daniel's got a long list of accomplishments, and I would encourage people to take a look at where he's been, what he's been up to. Certainly, he's been on the front page of a lot of the tribal interactions on, fair and equitable opportunities in the energy sector. CJ is the energy director for the Crow Nation, and he's tasked with how do you monetize the resource in a decarbonization energy transition world. And my hat's off to CJ for that challenge that he's got in front of him. Anything we can do to be helpful, certainly here to do. And I had the pleasure of calling both gentlemen very good friends, and look forward to more. And with that, I'm going to turn it over to both Daniel and CJ. And thank you guys for doing this with us. And all yours, buddy.
Well, thanks, Mike. Thanks, Marina, and the rest of the team here. That's part of USCA. Thank you for this opportunity to work with us as a team on this series. Like Mike mentioned, CJ Stewart and I were partners on this National Tribal Energy Roundtable series that we've been doing for the last year or so. This is the seventh. We had six earlier webinars that we did over the last year or so, and you can find those on USDA's website as well, and their YouTube channel. They're recorded, and you can watch those at your discretion. If you miss, obviously we have folks on right now, but and many of them are viewers who have watched us in the past. So thank you to the viewers who have made time this morning to watch. Again, this is the first of our next series, and so we've had a little bit of some issues, me personally, and so I apologize for the notice. But as we move along, we'll get earlier notice and more advanced notice for these meetings, and these webinars and these discussions and dialogues, basically. And so I just wanted to say that. I wanted also to have CJ, if you wanted to say a few words before we start.
Sure. Yeah, thank you, Daniel. I want to first of all, I want to say thank you to USCA, Marina, Mike, Alex. We've had some good success in the past with our support there with USCA, and we were able to supply, I guess, the folks out there that are willing to watch these, and there's a lot of them that come on and reach out, and with all this information, and we're happy to be able to showcase some of the individuals here that are experts in the field and are doing good things, and we're excited about the direct air capture. I come from a fossil fuel tribe, so we're doing things to try to make things better for not only our environment, our region, but the world. And we're trying to advance in technologies that are going to be spearheading some of the the standards that we're looking at meeting in the nation here, and we're just trying to supply our audience with information that they can utilize not only with their tribe but with their respective businesses and partners and folks and just to let people know that, you know, Indian country is alive and well, and that we're going forward, and that in some cases we might need some help. In some cases we're willing to prove up, you know, a lot of the things that are going on, you know, that with the technology. I mean, with fossil fuel tribes, you know, we're kind of out there, but yet we're willing to show the world that technology is something that is very, very great, and that we can utilize it and continue to move forward with the future, with stuff like with the direct air capture. I mean, it's huge. I mean, these are some huge opportunities and information. So I encourage everybody to get on and share these videos. I know we, like Daniel said, we're on our seventh one, and we had a lot of you know, folks reach out on a lot of the different topics that we put out there. And so we're gonna kind of delve into some of these topics and get a little bit more specific about some of these areas. And so I believe that's what Daniel and I have, you know, that's our goal, and that's kind of something that we're really pushing for. So I appreciate, and this is our second series of our next set of webinars. So thank you.
Thanks, CJ. And I'll and with your words, you reminded me. If you're a long-term viewer, thank you for viewing and watching, and interacting with your questions online and offline. But also, if you watched us, we really didn't talk a lot about ourselves, and not that that's going to change, but I did want to say one thing that relates to our second series of webinars during this roundtable is CJ and I are two of the co-founders of the National Tribal Energy Association, which you've heard us talk about, NTEA. We really haven't plugged our organization because we wanted to focus on our relationship with USCA. We wear a lot of different hats, and so technically we're here to represent Shasta Advisors, which is our firm, who is contracted with USCA in their cooperative agreement with the Fossil Energy and Carbon Management Office of DOE. But we work so much in Indian country where a lot of those distinctions aren't made, and so we just wanted to share with that. But the reason I mention that is because recently NTA, we've formed a partnership with the Colorado School of Mines, and recently May 20th and 21st, we had our first symposium of an initiative that NTEA and the Colorado School of Mines have formed, called the Native American Mining and Energy Sovereignty Initiative. So NAMES for short. And NAMES potentially we will continue to evolve to an actual policy center. And the reason I even mention that is because the NAMES initiative is trying to create an ecosystem, a platform for discussion and policy development in Indian country around energy, advanced energy, but also fossil energy. It also includes CCUS, renewables, energies of the future, and critical minerals in the mining side. So as we talk about the energy transition, mining is very critical to that. So in an academic way, we've wanted to create this platform. And to us, this webinar series, although not directly related, is related in a way to starting and continuing those dialogues in Indian country. So basically, we have two speakers, Susan Fancy and Matt Bright, and they'll introduce themselves. But the webinar, this energy roundtable isn't meant to be all inclusive, right? The subjects that we talk about today's subject, Director of Capture and Advanced CCUS Solutions for Tribes, you know, there are whole degrees and industries around this that, you know, we could spend days and you know, literally talking about this. And so it's not meant to be exhaustive. It's meant just to start the dialogue and the conversation and in the country and give tribes, tribal leaders, community members, and our supporters and allies out there ideas for the future. And so with that, I will introduce Susan Fancy from the University of Michigan and the Global CO2 Initiative.
Hi, I think it's good morning for most of you. Good afternoon, possibly. It's a pleasure to have your attention today. Thank you. And I would like to ask Marina to present my slides, please. And while she's doing that, I will tell you a little bit about myself. So I'm the Associate Director of the Global CO2 Initiative. We are housed at the University of Michigan, of course, in Michigan. And we think a lot about how do you turn waste carbon dioxide, which society sees as an opportunity and our climate definitely sees as a liability. How do you turn that into an opportunity for products? Next slide, please. So I'm the Associate Director. So what you see here are images. All of these products are made with captured carbon dioxide. On the upper right, you see cement blocks from a company called Carbon Built. And those include a large amount of captured CO2. That is a carbon neutral product. We have a hoodie down there at the lower left from a company called Craig Hopper, and running shoes and shorts from Nike. There's some hand sanitizer there from Air Company. They also make vodka. They're looking at commodity chemicals, and then there's also some soap. These are just a few examples, and in this case, we're looking at consumer products. There's also a really large opportunity in industrial products, which I'll talk about in a moment. They don't make for as attractive photographs, but I wanted to start with letting you see that even though it's very early stage technology, humans have figured out how to capture CO2 and how to do something with it. Next slide, please. And so as we go forward, we want to think about that further. So what you're looking at here is a chart from the Intergovernmental Panel on Climate Change. If you're not familiar with that, that is, you might have heard of, like, you know, COP26 or COP27 or the Paris Accord. It's all the same conversation about where countries come together and they talk about how do we get climate change under control. This chart that you're looking at, what we see on the left-hand axis, the y-axis, is gigatons of CO2 per year. And what we see on the x-axis there is time, you know, starting at 2010, running out to 2100. And this graph comes from the IPCC. That's about 2,000 scientists globally, by the way. These curves come from models. It's actually 40 models smashed together, the integrated assessment models that we use to understand the climate and predict its future behavior. And so what we see from the models up top there, that red line, is if humanity continues the relationship to fossil fuels in the same way as we have been, that's what our emissions in terms of gigatons per CO2 per year is going to look like. We're going to be pumping out about 40 gigatons a year, and that's a lot of carbon dioxide. The blue line represents the line we need to be on to get to net zero by 2050. And many of the INDCs or the individually nationally determined contributions from countries support that, not completely. but many countries have said, hey, we're going to be climate neutral by 2050 or whatever their goal is. And so that feeds into that. How we get there is the gray area, and that's avoided emissions. So that's those LED light bulbs, electric vehicles, walk instead of taking the bus or driving, eating lower on the food chain, moving away from fossil for electricity and heat, going to renewables, all of that stuff. So most of our progress as a society to get to carbon neutrality and to get the climate under control is in the avoided emissions space for the foreseeable future. But starting in around 2040, that green band is negative emissions. What that means, and you can see the little green graphic there on the right, is that we need to be planting trees, or in some cases, just not cutting down forests. That fan represents direct air capture. That is a process where we can, excuse the terminology, there's no polite word for it, but suck CO2 out of the air. If you say remove CO2 out of the air, it doesn't make sense to people. But where you suck CO2 out of the air and then do something with that. Also, there's a new field that's emerging, although I don't believe it applies to people on this call, for removing CO2 from water, especially from oceans, direct ocean capture, or possibly freshwater removal. So we need to be doing a lot of negative emissions soon. And so the question is, once we have all that CO2 for approaches that are taking it out of the air, what are we going to do with it? So that's what we think about. And I'm going to talk about that in a minute. And how much? So by 2050, APCC has said we need to be removing about 10 gigatons a year. And there are limits, very hard limits on nature-based approaches. There are only so many trees we can plant. There's competition for producing food, for biodiversity preservation. We need to plant every tree that we possibly can, but we can't get there that way alone. So we need to be removing CO2. And then we need to double that by 2100. So I wanted to explain this as the ground upon which we are standing. And from a tribe's perspective, where might you want to play in that green zone going forward? What's your role with that? Next slide, please. A little bit about us, the Global CO2 Initiative. Our bias is that we see carbon capture, carbon dioxide capture, and conversion as a mainstream carbon management solution long-term. Our mission is to provide intellectual leadership, of course, train students, other forms of education and outreach to get that done. And we want the CCU industry and believe that the industry can have global positive impacts on the environment, provide opportunities for a prosperous net zero carbon economy, and provide benefits to disadvantaged communities. We're very passionate about that we're passionate about all these points, but especially about the last one. If we invent this new field of CCU in the same way that we did the Industrial Revolution, we will have failed. We need to do this in a very different way. So, and I think so far we're seeing lots of good examples where that's being done, but next slide, please. So, oops, sorry, Marina, I left in a few, if you could just fast forward through the, yeah, thank you. So why do we want to capture carbon dioxide and use it in product manufacture? To, first of all, most importantly, to mitigate the impacts of climate change. How do we do that? We can, through direct air capture, again, we're sucking CO2 out of the ambient atmosphere. So think about this in terms of those legacy emissions. We already emitted them. And so if we're taking them back down from the atmosphere, we're taking them out. The CO2 concentration in the atmosphere is 0.01%. Takes a lot of effort to do that. But it's possible, and particularly desert environments are very good environments to do so. There's land that is not easily utilizable for other things. And those are good sites for direct air capture. We also, though, want to capture from as many point source emissions as is possible, especially between now and 2050. Point source capture, the CO2 concentration is much higher. It's 10 to 20%. So if we can capture out of a coal plant, out of a natural gas plant, out of a steel plant, at 10 to 20% concentration, rather than trying to catch it later at 0.01, that makes sense. Where it does not make sense is to use it to justify future new fossil sources, especially when renewables could do an equivalent job. And of course, I'm assuming everybody on the call is familiar with the idea that we need to figure out how to handle base load. There are limits to how many batteries we can install. And perhaps some of you are much better educated on that front than I am. And I'm not completely clear on what the thinking is right now and how to keep the grid stable, but coming back to what I was trying to say, so I don't know, maybe we're going to need some point source emissions long term, or maybe it's going to be nuclear, or maybe we're going to have batteries. But while we have a tremendous number of operating fossil assets, we should be capturing that CO2 and we should be doing something with it. We're also going to need it for long-term industries such as cement and steel, for example, and other industrial processes. So we can capture CO2 through direct air capture. We can capture it from point sources. And why would we want to use that in products? So it's a new source of carbon. The products that I showed you a picture of on the previous page, many of those are made from fossil sources. It's kind of a little known fact. We use fossil for heat, we use it for electricity, but we also use it to make a heck of a lot of stuff. So we can use it for that, especially in places where you can't store carbon dioxide geologically. And what I mean by that is we can pump CO2 underground. I'll get to that in a minute. And then the last reason why you might want to use carbon dioxide in products is that the public responds to using CO2 in products very positively. Whether we like it or not, sustainability is the answer to the make, take, waste cycle. The circularity of that is something that is not natural. And so if we can reuse CO2, the public has a much more favorable impression of that as compared to sticking it underground in geologic storage. Next slide, please. So what are tomorrow's non-fossil carbon feedstocks? I like to sometimes tell the story of Dow Chemical. 70% of Dow Chemical's feedstocks as of, I don't know, 7, 8 years ago were fossil-based. That's making all the plastics, all the commodity chemicals, all the pharmaceuticals, all the fertilizers. And that is not a plan for 2050 or 2100. So where are those non-fossil carbon feedstocks coming from? We really only have 3 choices. It can come from plants. So things like, trees, algae, bamboo, and it can come from recycling, especially plastics, but also some materials, or it could come from carbon capture. Next slide, please. So what is carbon capture and utilization? Let's look at one example. What you see on the left is a cement factory. And this particular plant actually doesn't have carbon capture yet. They're working on it. But you can capture, again, that's a point source. You could capture the CO2 coming out of that smokestack. Cement plants make a lot of CO2. That particular one is 1 million tons a year. So it's a lot. On the right-hand side is a direct air capture plant. That's a Climeworks plant. And that is removing CO2 from the ambient atmosphere. You could capture CO2 in one of these two ways, and especially in the cement plant thinking, you could make ready-mix concrete. You could make aggregates. And when I say aggregates, you and I might think rocks, but what I really want you to think is sand. Particles that are sand size or smaller. Those are widely used in construction materials. They're used in concrete, but they're also used in asphalt, just as general materials. And you can put a whole lot of CO2 into alkaline minerals. So anything with calcium and magnesium will, calcium and magnesium salts will readily absorb CO2. All you have to do is expose, the particle to the carbon dioxide, and it sucks it up. You don't have to add energy for it to happen. The smaller the particle, the greater the CO2 uptake. So you could make aggregates, you could make repair mortar, you could make precast concrete by curing concrete, which may have already precarbonated aggregates in it. So you can make those cement blocks that we saw in that first slide. You could 3D print concrete, you can make other products. So, and this is just one example. There are a lot of conversion pathways. And next slide, please. We'll take a look at some of those. So we like to think in terms of how big are the global markets for products that use CO2, waste CO2 as a feedstock. We are on our second iteration of market study. We did one in 2016. We released our second one, an update on that in 2022. The global market is 2 to 27 gigatons of CO2 per year. And it's a market opportunity globally of $1.1 to $4.4 trillion. And on a $26 trillion global economy, that's not bad. Those are in today's dollars. So what are the kind of the high level categories? First of all, those construction materials. The reason I highlighted that is that it's the largest, one of the largest markets. It's the largest durable storage market. So a new idea that I want to introduce on this slide is track 1 materials. Those will store CO2 for at least 100 years. And in the case of construction materials, it's forever storage unless you heat them up, but nobody's going to heat these things up, hopefully to 2000 degrees. So as long as they're kept at reasonable temperatures, if you put CO2 into aggregates or concrete, or aggregates and asphalt, it's never coming back out. So it's permanent storage, which is really exciting. And there's up to $1 trillion market opportunity that can use up to almost 10 gigatons of CO2 per year. And that's exciting because, again, we need 10 gigatons in 2050 and double that by 2100. We could get almost half the way with construction materials alone. That is really good news. The challenge with construction materials is that they are heavy. And the supply chains are decentralized and local, as they should be, because they are heavy. We don't want to be burning up a whole lot of fossil fuels to haul around, sustainable materials. So it's a matter of working with over 2,000 ready mix plants. These tend to be small, locally owned, and bringing in the concept of carbonated aggregates to the mining processes, which is something that I wonder about with tribes on the call is, are you mining aggregates? Have you thought about carbonating them? Do you have CO2 sources for that? What does that look like? There are opportunities for you in the 45Q tax credit opportunity, and then also with possibly selling the carbon offsets in the carbon markets. And yes, the carbon markets are a mess. They're going to have to fix themselves. There's a lot of good work going on there, but there's a real opportunity there. So I wondered about that with what the tribes are doing. Another opportunity is fuels, particularly sustainable aviation fuel. That's a track 2 material. So this is where we are not storing CO2 durably. Instead, we are using the CO2 in a circular manner. So we're going to capture a molecule, we're going to turn it into a fuel, we're going to burn it, and we're going to capture, an equivalent molecule and repeat that process. So up to $2 trillion a year. And again, a lot of CO2 potential for that. And there's a lot of good work going on in this space. Sustainable aviation fuel does adapt itself well to a large corporatized production facility. It in fact demands that. So these are large facilities that need to make many tens of thousands of gallons of fuel on a regular basis to survive financially. Then there's chemicals, commodity chemicals. Those again are mostly tracked too. So think like formic acid, methanol, syngas, all the chemical intermediates. The market size and CO2 sequestration potential size are much smaller simply because the markets themselves are much smaller. And then there's pure carbon materials, things like carbon nanotubes, carbon fiber, carbon black. Even smaller market yet, again, just because we don't use as many of these materials globally as a society. Plastics, well, there's a market there. There's also, though, a market for just recycled plastics. There's some interesting differences. Anytime you're on a second generation plastic, the properties as a generality, you've got to be really specific depending on the material, but oftentimes recycled materials for plastics, the second generation characteristics may not be identical to the first generation characteristics, and that can be a problem. Where CCU can shine is you can capture CO2, bring in some hydrogen that is made sustainably, not from steam methane reforming. And once you have captured CO2 and green hydrogen, you can synthesize any hydrocarbon. So it's the same as a fossil manufactured molecule. And then last but not least is food. And humans aren't terribly excited about eating products made from captured carbon dioxide, but the fish and the cows don't mind. And so you can make fish food, powders that cows can eat. And of course, it might be possible to do carbonated beverages. I do think there's some work going on with that over in Europe. So these are some broad categories. And I just want to say, how did we come to these conclusions? I really like our methodology. What we did was we worked with some really smart people like McKinsey and Lux, who really understand markets, to figure out how big are the incumbent markets for these products. And how big are those markets today? How much are they going to grow between now and 2050? And then what slice of those markets, what are reasonable assumptions for what CCU products can take in terms of slices of those products? That's the numbers that you see in front of you. They could be bigger, and we hope they're bigger over time. This is a small percentage of what is possible. Also a caveat, our methodology does not say that the trained workforce is there, that the investor capital is there, that the renewables are planned in grid expansions. It doesn't say any of that exists. This is simply market potential. So I just want to be really, really clear about that. Next slide, please. Here are some startups moving the needle. I know there's another one we're going to hear from today. On the capture side, companies like Svante or Mission Zero, compact membrane systems. On the products, on the conversion pathway side, there's a lot of great work going on in carbonated aggregates, companies like Blue Planet or Carbon Free, Pebble, making calcium carbonate, or Sky Nano, they're doing carbon nanotubes. Company that I'd love to highlight, I mentioned this to Daniel once, but there is a very interesting company. They're actually Michigan-based, but they're working in Wyoming. It's called Cowboy Clean Fuels. They are injecting bacteria into coal seams that increases their rate of CO2 production. So basically they're producing CO2 and then that CO2 is being captured. So while the energy transition is going on and there still are coal seams, it's just a way to extract more value and capture the CO2 at the same time. So that's kind of an exciting process. And then LanzaTech is doing a lot of great work. So these are just a few examples. Next slide, please. And here I just want to highlight the concept of life cycle assessment. Life cycle assessment is a process where, let's pretend that you want to make carbonated aggregates. You want to carbonate some, let's say you want to crush up concrete that you're salvaging out of buildings and add CO2 to it. You would, in a life cycle assessment for that product, you would look at the energy it takes to remove that concrete from the building site, transporting it, crushing it up, adding the CO2, including the emissions associated with capturing that CO2, any processing of it, and then delivering a finished product either to the gate, your company gate, factory gate, or to the grave, to recycling. So that's a life cycle assessment. And that's where you look at the CO2 emissions impacts, you look at the impacts on water, and many, many other environmental factors and increasingly health factors as well. So you can't really understand if a product that is capturing CO2 is doing good unless you do a life cycle assessment. One of the things that we see a lot that really bothers us is that there's a lot of carbon footprint calculators out there, and people don't understand the difference between a carbon footprint calculator and a life cycle assessment. A life cycle assessment is very, very specific. It is site specific, it is product specific, it is supply chain specific, and a product that you may want to make in Michigan may not be successful in Indian country and vice versa. You have to look at it. You know, like for example, in Michigan right now, I don't know where we're at on our base grid. I think in my area, it's still like, I don't know, 65% coal or something. So if you weren't running on renewables, you don't want to make anything from a CCU product here, unless you've got dedicated renewables somehow. So, so life cycle assessment is really, really important. And we are life cycle assessment experts, by the way. We have guidelines on how to do this that have been around for almost 10 years now. They are being turned into standards. And what we're looking at on this chart is where, you know, for where the CO2 is coming from and then where it's going. What's the sweet spot for the climate? And what we see in that dark green box is construction materials made from direct air capture, biomass capture, or water capture have the best, they have the potential to be negative emissions with a good economic return. Some of these other processes that society is doing right now, including capturing CO2 in smokestacks, geological storage, we need to be doing them. Just because they are labeled orange and red on this chart doesn't mean we shouldn't be doing them. We should be doing them. We need to be engaging every positive solution we can. What we're trying to highlight here is from a life cycle perspective in terms of what are the emissions benefits on the climate. Putting CO2 that's captured from air, water, or biomass into construction materials or special materials is the best plan, especially long term. Next slide, please. Because it's really easy, you know, what we hear, we just hear so much confusion, like I heard, you know, somebody just a few weeks ago, not understand about enhanced oil recovery, using CO2 for enhanced oil recovery. They thought that that was a carbon negative process. No, it's not on a life cycle basis. And so we need to clarify these things. We also did a study regionally. It'd be interesting to see what this, the reason I wanted to go through this today is, you know, what does this look like from a tribal perspective? We did a study for the Great Lakes region. So I'm in Michigan. And so we're bordered by all the Great Lakes. And so we looked at the 8 states here in the US that are touched by the Great Lakes and then two Canadian provinces. We did a study for a little nonprofit that's dedicated to sustainable economic development. They wanted to know how to make our region a go-to region for carbon offsets. They saw and see that as new economic revenue. And so they were only interested in looking at that durable carbon storage. They weren't interested in sustainable aviation fuel or short-lived plastics. So we looked at reforestation, aggregates, precast concrete, and geologic storage. And we did the same thing. We looked at how big is the market and how much CO2 can it suck up or use. And what we learned is that on public lands, those are already really well managed. Not surprisingly, if you're managing forests for biodiversity, for hunting, for recreation, you're by definition managing it well for CO2. On private lands, whole different opportunity. Those are private landowners who are not managing their lands well, often for things they can see, much less for something they can't. So there's good opportunity there and lots of good work on the ground going on to aggregate smaller landowners into larger conglomerates so that they can play in the carbon offset markets. Aggregates and construction, huge opportunity there. Precast concrete, same thing. And then a lot of opportunity for geologic storage, both, and you can see in that lower left-hand corner, a direct air capture, that's with the little fans, and then also the point source capture. And in our region, and I know there's good opportunity out west as well, look at how much potential revenue there is in terms of dollars, and up to 51 gigatons, 52 gigatons of CO2. This is cumulative in this case. The previous slide was annually. This is cumulatively. The basic conclusion was we can easily balance the region's emissions of 1.5 gigatons a year with lots to sell. Next slide, please. I think I might skip over the next slides because I talked a little longer than I mentioned. Yeah, we'll skip that. And then last but not least, we also did a study on, it's kind of an interesting thing to if you were to pick one or two of your large point sources that you have in Indian country, that you know you need to operate for at least another 30, 40 years, I would say, at least 25. What products could you make with that waste stream? What does that look like? We did that for a cement plant here in Michigan, and here were the answers for our area. Construction materials, and I think that's going to be true everywhere. Again, ready-mix concrete, precast, CO2 sequestered aggregates. That could include cement kill dust, steel slag, fly ash, ground up concrete. If it's got calcium and magnesium in it, it's a good candidate for CO2 sequestration. And I heard somebody mention critical minerals extraction. I don't know if anybody's done, I know that a number of entities that I've talked to privately have looked at critical minerals extraction out of waste, especially out of fly ash. And the economics don't pencil, at least around here. I don't know how regional that is. I don't know anybody who's looked at what if you were to extract the critical minerals out of fly ash and carbonate it and look at, is there economic opportunity then to put that carbonated fly ash into the local concrete supply chain? I think that would be a really interesting thing to look at. I don't know that it would be that complicated to do either. So that was one idea I wanted to mention for whoever said that on the call about critical minerals extraction. Chemicals, so methanol, syngas, urea. Now we're a large industrial. We've got a lot of industry around here. So, those are things that our local industries can use. And that is a good way to think about it. If you're going to capture CO2 and sequester it, which I know is being looked at for out west, I just really encourage you to think of, and then what are the local supply chains for products that can use CO2 and how can we plug into those possibly economically? And then farming and then carbon black products. Next slide, please. And I believe last slide. Okay, we can skip this, Marina. Yeah, we can just skip this one, sorry. And then if for some reason you need something from me, I am here. I also know Daniel really well. He knows where to find me. So I'm going to pause. Thank you.
Well, thanks a lot, Susan. This is a lot of information. really great information. And I just wanted to make a comment or two, not questions, and we can leave the questions for the end. Is one of the comments was, given the 45Q tax credits that exist, and those are really around sequestration. If you capture and sequester the CO2, you get a certain tax credit. And I think over the next 12 years, it's a 12-year time period for you to get that credit. And that what that's going to do is build infrastructure. It's going to build carbon capture infrastructure at the point sources. It's going to help again with direct air capture. It's going to help with the transportation of CO2 via pipeline, and then also with the sequestration infrastructure. But what happens in year 13 when the credit's no longer there? And so I think Susan's brought up a lot of great points, a lot of information for tribes to digest, looking about how we can participate in this the carbon cycle and recycling and conversion of CO2 and carbon, and making that a thing. You know, it already is a thing, but a bigger, more of a thing as we move forward, and being part of that conversation. I think that and that's why I wanted to have Susan speak, is because this is what we have to start thinking about beyond the 45Q. And so I wanted to make that point. And then second, the opportunity that Susan mentions as well, or talks about all the work that that her center, the Global CO2 Initiative, and the University of Michigan have done. A lot of great and smart folks doing a lot of good work, and the opportunities potentially to partner with tribal higher education, the tribal college system, with other initiatives. For instance, like I'd mentioned, our NAMES initiative with the Colorado School of Mines, and the potentiality to look at Indian country. Susan had mentioned the studies that they've done on individual, say, power plants or individual cement plants, or regional studies. And a lot of times Indian country is included in a lot of these different regions. So basically it when we're included with other states in these regions, the impact of Indian country is sort of diluted. But if we did studies where all of Indian country was one region, I think that would sort of collectively look at what the potentialities are in terms of not just revenue creation and job creation, but how we in Indian country can be part of the solution as we move forward. And so I just wanted to say that. Thank you, Susan. And hopefully we'll have a lot of good questions at the end. And then I wanted to introduce Matt Bright, will be our next speaker from Carbon Capture Inc.
Great. Thank you, Daniel. I appreciate it. I'm going to share my screen. Oh, it says host disabled participant screen sharing. So I don't know, Maria, if you have my slides.
You should now be able to share, Matt.
Okay, great. Excellent. All right, great. Assuming everybody can see my screen, I think important to highlight that direct air capture, I work for a direct air capture company, both the technology as well as a project development company. The human side, as you can see on our screen here, I think we're trying to shift our global economy and the United States economy from one that's been based, primarily on fossil fuels, which has made this country enormously wealthy, to one that's a little bit more environmentally friendly, solving climate change, which hopefully our kids will thank us for. So the human side of thing is very much what I work with as the Director of External Affairs, and working with the tribes. I think this is a new opportunity to start an entire industry, carbon management, working with tribes from the beginning rather than the way it's been done in our history, which is largely the tribes being an afterthought, which has been a real mistake. So who we are, Carbon Capture Inc. We are a company who develops and deploys DAC machines. DAC stands for direct air capture. So as Susan pointed out, we just suck carbon dioxide right out of the atmosphere, just filter it out. Our company is headquartered in Los Angeles. We have a team of 65 employees there, and just a month ago, or I guess 3 weeks ago, we unveiled our first direct air capture module that is removing 500 tons per year of CO2. So you can see that module right there. That's not a rendering. That's actually a live picture of our first module, which we named Leo. And we've pre-sold $27 million in carbon removal credits. We've raised over $90 million. Our primary investors are Prime Movers Lab, Amazon, Aramco Ventures, and Siemens. And we are focused on developing Project Bison in Wyoming, and would like the Wind River tribes to be a big part of that. So I think just quickly, one thing that everyone should understand, Susan brought more of the academic perspective, I bring more of the business perspective, is that climate change is going to be solved by for-profit companies. And so we need to make money. How does our company make money? We sell carbon removal credits to companies with decarbonization goals. So you can see these are some of the companies we have sold credits to: Microsoft, Stripe, etc. All of them have decarbonization goals. They've told their shareholders our company is going to be decarbonized or net zero by 2040 or 45 or 50, etc. And most of them can't do it without sucking some CO2 out of the atmosphere. So they're going to continue to have trouble. They're going to be putting more CO2 in the atmosphere, and they need the counterbalance of CDR to help them with that. So we have signed deals with these companies. The estimates for what the market is going to look like is $10 to $40 billion by 2030. Back to our sort of technology development, we are incrementally deploying larger installations, larger projects from our modular technology. So we want to be to million megaton scale, which means millions of tons of direct air capture per year. Starting in 26. This is where we've been so far. In 2022, we started out with a reactor, which is just a sort of fancy fans and filters that can remove kilograms, tens of kilograms of CO2. Back in 2022, in 2024, just a couple weeks ago, we released our first fully functional module, which has 12 of those commercial reactors that you see on the left side of the screen, with fancy fans and filters in that shipping container size machine there. Just did that in Los Angeles. In 2025, next year, we will have our first commercial project down in Phoenix, removing CO2 at the 2,000 ton per year schedule, and then going out. So to capture CO2 from air, our system cycles solid sorbents through low, what we call temperature vacuum swing adsorption. So essentially, this is fairly conceptually simple. You're just heating up the filters and then you're cooling them down. So when the filter is cooled down, it adsorbs CO2. That just means that the CO2 sticks to the filter. And then you have an evacuation phase where you essentially make sure that all the CO2 is there, and you heat up the filter, and that the CO2 falls off the filter, and then you repeat this entire cycle. Carbon capture's direct air capture systems are based on a patented modular open systems architecture. And essentially all this means is that we start with a structured sorbent, which is chemistry and physics. So you can think of it as the chemistry is actually how CO2 attaches to the sorbent. The physics part of it is that you can structure it in a certain way to capture CO2 more fully. So the structured sorbents go into cartridges, which then go into reactors. The reactors, like an airplane engine size thing, modules, clusters, and then bigger project arrays. This modular system architecture enables us, how we think we're going to bring down costs is that we can continually upgrade. So sorbents are getting better and better. We have an in-house research team of about 5 people, but we also work with universities to work on what are the best sorbents to be able to capture CO2 more efficiently. So we're already getting better from our original module that we even released 3 weeks ago. We're looking at next scale ups as quickly as possible. And once you put the entire process together, so to be clear, what we do is we make those direct air capture modules that can remove CO2. We don't do anything with the CO2 once we've captured it. So we need to work with partners who can either inject the carbon dioxide underground, which we're going to be doing some of that, or putting it into products, as Susan was talking about, either into concrete or that sort of thing, concrete, sustainable aviation fuel, etc. So we have energy that, upstream, we need clean energy because we need to be making sure that we're not putting carbon dioxide into the atmosphere with our left hand while we're moving it with our right hand. So we have energy needs, and then we have our storage and offtake needs. So we have been selected to be the prime on what's called the Direct Air Capture Hub. The Department of Energy, through the Bipartisan Infrastructure Law, created the DAC Hubs program, which they funded at $3.5 billion total. We were selected for a topic area 2 direct air capture hub. So that will be $24 million of total investment in 2024 to 2026, 12 million from DOE. And so 12 million from DOE, 12 million from us. So it's a 50-50 cost share. What we are aiming for is to be one of the top 4 finalists. So 2 of the finalists have been selected, one in Louisiana, one in Texas, but we are aiming for the state of Wyoming to be one of the big remaining 2 finalists, which would come with, $600 million or more of additional funding. So the next 2 years, what we're going to be working on is doing a big feed study for a 200,000 ton per year facility in Wyoming, a feed study for sustainable aviation fuel, that's SAF, and then a $2 million community benefits plan. So you might wonder, why Wyoming for direct air capture? And this gets into some of the tribal, how can the tribes be involved? Wyoming is very important for DAC because it is a global leader in carbon management. It has excellent geology for permanent and safe carbon dioxide storage. It's got energy industry skill sets. So think of oil and gas, poking holes into the ground. If you're able to take carbon out of the earth, putting carbon back into the earth, the skill sets are pretty similar. And then locally in the state of Wyoming, the Department of Environmental Quality has the expertise and the ability to do the Class 6 well permitting for an injection well. And that's very important because they move faster than the EPA. And so assets that Wyoming has right now, I think the biggest thing is to note here is that Wyoming has been investing in carbon management, both point source carbon capture as well as direct air capture for many, many years. And you can see that the big green lines are CO2 pipelines. The gray ones or the green ones are proposed, the gray ones are existing. And so you can see that there's already a lot of, once you've captured a molecule of CO2, there's ability to move it around the state as well as put it underground. We would like to see that be built up even more. That would be helpful to us, but these are the reasons why Wyoming is really attractive. So what we're looking at doing is making Wyoming a regional direct air capture hub. And we, if we're doing this, the way we look at this as a company is that if we're working with the state of Wyoming, that means you need to work with everybody in the state. And the Wind River tribes, Northern Arapaho, Eastern Shoshone have been there, since the beginning. And so they should be a part of this direct air capture hub. So as you can see, these are our anchor partners. We've got FEED studies that I already mentioned, but on the right-hand side, our hub-specific activities as it comes to community investment is that we want to work on workforce training with the tribes, internships, scholarships, community benefits agreements, conservation projects. And you can see, the Eastern Shoshone and the Northern Arapaho live, their reservation is sort of right there in the central northwestern part of the state. And if you can recall back a couple slides before, there's already a lot of carbon sort of pipeline activity going up there as well as oil fields. And so some of the same areas, there is the ability to be able to sequester CO2 there. So community engagement, specifically what my role as the Director of External Affairs is doing a lot of the community engagement. And what we're really going to be focused on in the next couple of years, we do not have an existing relationship with the Wind River tribes, and that takes a lot of time to build trust. And so we are going to be investing in forming those relationships in conservation and in workforce development, because we feel like that's a really good way to introduce potential future of project development with the tribes, is to really work with building the relationships and investing things that are already important to the tribes. So we plan to invest in a conservation project with bison that's already going on there with the Wind River tribes, to see, native buffalo habitats expanded. And that is also carbon sequestration too, because these animals have been working with natural systems to do that for a long time. Also career training. We want to socialize the idea that there will be good jobs in Indian country for direct air capture. And that's all of the things that you see the menu of options there: plant operations, electrical instrumentation, fabrication, construction, welding, etc. So this is really, we have a whole host at our company currently down in Los Angeles. We have everyone from very blue collar welders and fabricators up to, very highly educated PhDs in chemistry and physics and engineers and that sort of stuff. So I think that the great thing about direct air capture is that the jobs and the skill sets really span. If you don't want to go to college, that's fine. You could still work in direct air capture. If you do, great, you can work in direct air capture too. So we want to make sure that our training for jobs includes tribal members and has the ability to train them for whatever skills they would like. So I think finally, just our commitment to communities, we are built on these pillars: transparency, dependability, conservation. We think this is very important, especially with the tribes. Transparency, dependability, and then conservation, caring about the land. So, for questions, feel free to reach out to me. That's my email address, mbright@carboncapture.com, and happy to answer any questions now.
Well, thanks, Matt. I wanted to make a comment or two and then open it up for CJ if he has any comments as well. But I wanted to invite Matt to present, because not only is his company working right now today on direct air capture, so it's an existing technology that's really in its infancy. There's a lot of competition, but I think like I said, I'm biased, but my view is that carbon capturing, with its technology where it's at, what its plans for, especially around Indian country, and then the backers, the financial backers, as well as the clients who have bought the carbon credits and those financial mechanisms, I think have the best chance of any of the competition, I think, to exist in the decades moving forward. And so I wanted to be able to contrast that with what Susan had talked about in terms of creating, talking about carbon conversion and taking CO2 once it's captured, whether it's from direct air capture or point sources, like existing facilities, and then what do you do with it? And so we've talked about a lot of the terms around 45Q, and I think the point that you made, Matt, I think at the beginning is important, is that in order for this to happen, in order for our energy transition and for us to meet our Paris Accord requirements, which takes capturing CO2 as the foundational goal, these companies need to make money. And so and mechanisms and incentives from the feds, as well as state level incentives like the 45Q, help us get to that point. It's not everything, and it's in the 45Q, especially around direct air capture, needs to evolve more. And I think as this happens, as Congress and our politicians see what's working, what's not working, those incentives will be tweaked as we move forward, because we've already seen that, right? We've already seen the incentives. They were different just a couple years ago before IRA, and so and I think they will continue to evolve and be much more which adds more complexities to things, and so I wanted to illustrate to tribes, to tribal communities, the opportunity that not only direct air capture and carbon conversion can bring to Indian country, but also the complexities, and so where we can be in the next 10 or 20 or 30 years, right? Because in Indian country, we always talk about 7 generations. We always talk about the future. We talk about our past, we talk about our ancestors and the generations before us, and we talk about our future generations. And I think this is one area where, like in Susan's presentation, we're thinking out to 2100 and beyond. None of us on this call will be alive then, and so it's how our children and our grandchildren and the next generations, what they do with that CO2 that we potentially capture, and how do they monetize that, and how do they create business and jobs around that. So I think we've done a really good job. I think the 2 speakers have done a really good job at illustrating the opportunity before us. And again, one of the things, and I've mentioned it before, but if you've been a long time listener and viewer of the series, is that much of the point source, the smaller do exist, right? much of the larger emissions have either been closed, and those were coal plants, primarily in the Four Corners area. Many of those have been closed down. A lot of the emissions are gone, and so realistically, most of the emissions sites are not on reservation. There are some close, and I think there's opportunities for that. But so that means that much of the opportunity, the current opportunity and future opportunity, is in the space, the direct air capture space, and then advanced CCUS space, where I would include carbon conversion, especially in Indian country, because as was mentioned, there's a lot of good geology in the United States. There's a lot of not good geology as well. West of the Mississippi, where most of Indian country resides, although there are pockets in Michigan and the Great Lakes, the Northeast and Maine, Florida, parts of the South, and in the Midwest, there are smaller pockets of Indian country, but the vast majority of Indian country is west of the Mississippi, including Alaska, and so for that part of the country, obviously the Gulf Coast is really good off of Louisiana and Texas, in the Central Valley of California, but beyond those, the rest of the space where Indian country lies is good geology in Montana, Wyoming, where Carbon Capture Inc. has its Project Bison, Wyoming, the Green River Basin, the Wind River Basin, the Powder River Basin are all good geology, and as well as in the Four Corners region, San Juan Basin is also a really good geology, outside of, and then also which is not an Indian country, but the Permian is also good geology, and so the opportunity, to me, for over a 12-year period at least, because of 45Q, is in sequestration. The biggest opportunity that's going to impact Indian country is in sequestering the CO2 geologically in the ground, permanently, because that's where there's money to be made, like Susan mentioned in one of the studies that was done in the Great Lakes, that that's an opportunity, and that's to me the biggest opportunity for Indian country monetarily in the short term is sequestration. But that same 45Q is also be paying for transportation to take the CO2 from where it's emitted to where it needs to be sequestered, which is primarily Indian country, and then but the biggest opportunity I foresee is outside 45Q, when that CO2 still continues to need to be captured beyond the incentive phase, and then what do you do with it? And I think as we start to talk about conversion and those technologies start to get improved, I think then tribes will be at the right place at the right time to be able to take that CO2 and make chemicals, make all the commodities that she mentioned, as we start to truly transition, right? The transition that when we talk about it is primarily around electricity. Most of the conversation that we're having in the US is how do you take fossil energy, coal, natural gas, oil, that's being burned to make electricity, how do you transition that into renewables, solar and wind, but then how do you do it in a way where we can have stable grids, and that's where batteries come into play, and critical minerals and that whole piece. But like Susan mentioned in her first slide, was the shoes and the clothes and the chemicals and the pharmaceuticals and everything that runs our modern society and economy comes from fossil energy, comes from a fossil fuel. And so how do we convert, how do we transition out of those things into a greener and more sustainable world, and that's where carbon conversion comes into play. And that, again, that's happening now, but that's also happening over the next decades and past 2100. And so, to me, those are the opportunities that tribes can participate in, because the bottom line, and CJ's mentioned it before, but a lot of Indian country leaders have mentioned it, is we didn't create the problem, right? You know, we're a small percentage of the population. We've been isolated geographically, and we didn't create the emissions that got us here. Now we're all Americans, so we were part of a larger group that has caused the problem. So, you know, we need to be part of that solution. We need to be part of those conversations, to create those solutions. But I think we have an outsized role to play in the creation of the solutions. And so, again, I know we have some comments and some questions, and so I wasn't taking a look at them as we spoke. But CJ, if you wanted to make any closing comments or any comments before we start taking the questions. I think you're muted.
Sorry about that, guys. First of all, I just want to say, I want to thank Susan and Matt for coming on. I mean, these are some very important areas here, and the information that you presented is very, very interesting and important. And with me, as I'm not a scientist or anything like that. I look at my perspective on direct air capture and the products and the things that can come about from it. It is basically what you're showing, and I like to try to see stuff that we can utilize on a day-to-day basis. And then on top of that, get just the common native or crow to understand exactly what we're talking about here. I mean, just to the common layperson, I mean, when we're talking about fossil fuel development, we're talking about all they see is big trucks and Tonka trucks and digging up on black rocks. That's all it is. They don't know there's different types of coals, different qualities and blendings, and they don't realize when we're drilling for oil, they think you're just going to drill a hole and that's it. There's a lot involved, and trying to get into the specifics of those areas kind of bore a lot of people, but to have an understanding of the outcome of the products or the process of something such as carbon, direct air capture, that really entices an individual to have a better understanding and want to know more exactly with what's being presented and how we can create a marketable product, something that we just don't throw away, something that we can utilize, and just something we can utilize to make our world better and create jobs, and create an opportunity for heads of families to provide for their families. And so, I mean, these are some of the things I applaud you for, Susan, Matt. One of the things I want to mention too, Matt, on your end, have you guys considered speaking with the Crow tribe? I know that you mentioned those areas, and I know you've mentioned a couple of tribes there. But those areas there were those are all ancestral lands of the Crow people. So and with the Shoshone and Arapaho, treaties were signed, prior to them getting a tract of ground there. We worked with them on the water settlement, and they've worked with us, and it's one of those things that the Crow have about 2/3 of Montana and about, gosh, at least half of Wyoming, ancestral land. We have the maps and everything. yeah, we had about little over 40 million acres at one time in 1851 when it was first when our property description was first described in the treaty of the 1851 with the Wekulawaja. The chief at the time sits in the middle of the land is his name, and he outlined, and every area that he outlined with the four sacred lodge poles, and every area that he outlined, two are in Montana, two in Wyoming, and those areas are identified with tributaries. They're not just given a name like Sam's Ridge or something like that. No, they're identified with geological tributaries in the area. And that's the way the Crow tribe has always identified their property, through identifying the tributaries in those areas. And so that's something that I kind of think that would be very helpful to the understanding of direct air capture in Indian country, is if we get the original inhabitants of the land to have a better understanding. And we do have a tribal college. Our president of our college, he's done retired now, but he was the president for all presidents for all tribal colleges. So the Little Bighorn College is the Crow tribe's tribal college, the Little Bighorn College, and we're well known in Indian country when it comes to these areas. I think it would really help out a lot for being that the Crow tribe is always at the forefront with, even in the tribal colleges, that we would include these areas of study, such as direct air capture, all these different technologies that create opportunities for folks that want to produce these products. And I think that would really help our students and everyone that's going to these tribal colleges to have a better understanding. It's like I said, to the lay person, they just look at it as just this or that, and they don't realize the process of the whole ordeal is there's economics involved. I know we're talking about climate. I know we're talking about these areas like that, and we're trying to make some things work, but at the same time, we gotta have an understanding that we can't do that without people. And when it comes to the politics, people are your voters. And so we have to, I'm speaking as a politician right now, at this moment, kind of have to, because, we have to look at these areas, and I was asked one time, about, how solar and wind and different things like that would help Indian country. But I had to bring it up, and I said, well, I measure them as by their parking lots. How big's the solar farms parking lot or the wind farms parking lot? And you go to these fossil fuel plants, whether it's a refinery, mine, or at the oil fields or whatnot. There's a lot of jobs. And so I think it's in best interest, when someone feels like that they're going to get into a field of study to learn something, they feel like they want to get into that because they want to make some money from that particular field of study. Now, if they get into something that they feel like they probably won't have a chance to get a job, maybe they're competing for 1 or 4 jobs or something, for a wind farm or a solar farm or something. That just doesn't cut it. I mean, I'm not going to spend money to go learn something and pay money to a college coming out with debt, knowing full well that I'm gambling to even get a position, in those areas. And so that's just something I'm just trying to bring some real common sense logic to our conversations here. I know we get caught up with all the acronyms and and all these areas there, you know, we call direct air capture DAC and stuff like that. To the layperson, they don't know. So it's really helpful that we, you know, that Daniel and I, we've talked to this issue many times, that, you know, we want to have Indian country have a full and better understanding of what they would want to get into to meet these standards that we're looking at in the near future. And I believe we can do it. You know, technology has proven, you know, that we can do a lot of things, and there's a lot of smart people out there. We have a couple online right now with Matt and Susan here, and we appreciate you. And I think that, you know, this is going to be something that we're going to have to continue in the tribal college arena and areas such as that, because, you know, the Crow tribe is the largest private co-owner in the nation, and for us not to be a part of your study is just kind of funny, because, you know, we're the ancestral owners of the land, and, you know, we even have the hunting rights of all the mountains in those areas and tributaries and stuff. So I mean, it's just something that I think that needs to be and no fault to you, Matt, but I know that, you know, everybody's getting familiar with the area, and that, you know, I you know, just to make that a comment, that maybe that looking towards the, you know, get some support with the Crow tribe, I think that would probably really be helpful. And I appreciate all of you and everybody that's on this call. And I said I wasn't going to take too long, but I apologize. I know that what I'm bringing up is important, and I know that it's going to be something for the future. We're talking about things all the way up to 2100, so it'd be best to get a good sound understanding with our college students, our tribal college students, so in that way there's not so much opposition without any you know, they don't understand the situation, the information, and that they're just being led by you know, hearsay. And it'd be best that you know, we have this in the tribal colleges, so they have a better understanding of what we're doing here. They see the opportunities, for jobs, expansion in their knowledge and those areas. So I think that's something that I really stress. So I appreciate it. Again, thank you.
Thanks, CJ. It looks like Susan had to drop off, and thanks, Susan, as well. I'll email her afterwards to thank her. No, this has been great, and I think the obviously our audience are our tribal communities, the wider CCUS world, the direct air capture industry, but also the U.S. government and the DOE, because what I've been saying for a long time to them and to anybody that will listen, it's like a broken record, but that as we move forward and we start looking at right now the direct air capture industry is looking at the low-hanging fruit, right? The places where you can easily absorb CO2, like the Gulf Coast, from ambient humid air, like Central Valley in California, like Arizona, and the goal is to get the cost of capturing CO2 down to $100 or below per ton. Right now it's a lot higher, and
are you able to accept comments from any of the attendees? I'd love to share a solution with you that really speaks to what your colleague just mentioned. And I have funding that I'd like to put on the table that could help to demonstrate what we do in Indian country.
Well, we usually haven't set it up that way. We usually will take written comments, and we've got your comment there. Because we're running up against the time
can I just
that we
have
allotted.
Can I just have 3 minutes?
Okay.
Well, thank you very much for that. My name is Joe James. I have a message in the chat, which includes my website. I'm a former 33-year economic development professional, and I invented a process after I saw the poverty in rural communities in the South, by which we plant and then we multitask extremely fast-growing biocrops that capture 4 times the amount of carbon dioxide per acre as trees and twice as much as the next best crop that we know. And then from a job creation standpoint, we convert that plant material into a variety of bioproducts. Carbon black was mentioned earlier. We now make a bio-based alternative to carbon black that is not as toxic as the material that's currently being used to comprise 30% of a tire. In addition, we make biochar, and we're able to take the crops that capture 7 tons of CO2 per acre above ground and 1 ton of CO2 below ground, convert that not only into the other bioproducts, but into biochar that allows us to sequester the captured carbon extremely efficiently in the very same soil in which the crops were grown. We can also help remediate mining activity and convert some of the mining disturbed sites into carbon capture sites. So I have, like I said, my website is in my message. I'd love you to take a look at that and maybe respond to me by email. But I have a few tens of thousands of dollars right now that I could make to 1 or more Native American communities to have our crops planted this spring to demonstrate how they operate and how they create not only a way of capturing CO2 to combat climate change, but also beginning to create the very jobs that your colleague was concerned about, and converting the plant material into a variety of bioproducts and be part of a bioeconomy. My last comment is, we have been funded by an organization called BioMade. One word, BioMade. It's a federally funded organization that seeks to create a bioeconomy. I have a pending application there that could, if there's interest, and if the tribes have a desire to collaborate further, to include in that application some funding that could engage the tribes on an ongoing relationship with us to demonstrate our process that creates a bioeconomy, even as it captures lots of CO2. Thank you for the opportunity to make that comment before we close down. Please take a look or copy my message out of the chat box and contact me by email. I'll send you more details.
Well, thanks, Joe. Like I said, the point that you're making just adds to the conversation. And I wanted to say before we closed was that our next webinar, our 8th webinar, but 2nd of this new series, is entitled Energy Technologies and Research and Development, Conceptualization, Scientific Research, Commercialization, and Options for Indian Country. That's going to be July 30th. But and really the what you're talking about is in this world of the Paris Accords and 2 degrees Celsius and the energy transition and CO2 in general, is that there's not one answer.
That's right.
There's going to be multiple answers that have to work together. And so there's no like the new sliced bread, or there's nothing that that all these technologies have to work together. And
That's
so
right.
the point being, our second our next webinar is going to start talking about the technologies that are out there, like maybe that what you're talking about with your technology, but basically trying to look at, and I've been saying this in Indian Country for the last 30 years as well, since I first was elected to my tribe's council, was we need research and development infrastructure so that we can, our people, our smart folks, our youth can come up with ideas and technologies and work them out.
I agree with that. I agree with that 100%. In fact, we've worked with HBCUs, and we'd love to work with tribal institutions as well, and have them as partners.
Well, Joe, as you see once we'll come out with our marketing for our next webinar. And you know, you know, hopefully you'll be able to sign up and participate. But that's really, I think, where that conversation needs to be had. And I you know, but again, like I said, before we leave, you know, I wanted to thank Matt, Susan, towards contributing to this conversation. We didn't get a lot of questions, but there was a question from from Ben about when the presentations will be made available. I'll leave that up to Marina and the team. Usually it's about a week, a couple days to a week or so, when we'll get the depending on how busy the team is, the video there'll be a link to the archive where the video will reside, and then if there's any the presentations will be made available as well on the website that was created for this webinar. And usually it's about a week. But Marina maybe can speak to that.
Yes, thank you, Daniel. Yes, the recording of this video will be made available on the website, and I will put the direct link in the chat, hopefully by the end of this week. And Susan's presentation will also be available for download. And I'm sorry we ran out a little longer than anticipated. I know we're all very busy, but thank you very much for joining us this afternoon. And special thanks to our speakers and also to our moderators, Daniel and CJ. And we hope to see you all at our next webinar.
Thank you, guys.
Thanks, Daniel. Thanks, CJ and everybody.